Okay. So, can you see my screen? I think that you can see my whiteboard. Uh, okay, can you see?
Yes, Sashi.
Okay. So, this is your homework, and this is the question, and you have to draw the excavation line around the pit, and so now, mm, I think you know this is the elevation of this point, and this and it's the right side, left side, and this is elevation of the right side. So they are different. They are different, and the at the bottom of the foundation of the pit, the elevation is 0. Okay, so it's a very old question about when you get the elevation of two horizontal surface, um, for example, and then for example it's 2 and it's 0, and then you can get the difference of the elevation. Okay, so I will say slowly. So at first. At first, you have the difference of the elevation. It's 2. It's 2. I will repeat it again. H is equals to 2. Okay, and the next one, you know the slope. Okay, it's slope. The slope is 1 to 1. And then, uh, so please look at and listen carefully. You already know the h, the difference of elevation, and the slope I. And then you have to calculate L. It's the horizontal direction. It's the horizontal direction. And so what should we do next? What should we do next? Can you tell me? So how to calculate L? So when you face this problem, okay, at first I think you should draw a slope like this, and you have to put 1 to 1 at here, and then h and l. H is equal to 2, and the slope is 1 to 1. And how about L? L is also 2. Okay?
Also,
Okay. So, and anyone have problem? Who if you have any question, so you can tell me, or you can tell me. And so we can calculate L from the I and H. And then so how can we draw two unit in the drawing in this picture? So now we have to use the scale ruler. Here you can see the 0, 2. Okay, this distance is 2 unit. 2 unit, and then we put it here. Okay, and so in this way we can draw a line from this point and parallel to the and parallel to this edge, parallel to this edge, and then I'll prolong it. Okay, with the same procedure, this distance, this elevation is 3, and this one is 0. So the difference is 3, and the slope is also 1 to 1. Okay, and so with this way we can get this line. Oh, okay, this line. The same with this one. So now I'm going to measure 3 units. 3 units. Okay, like this. And then when you draw on your paper, and you can use your ruler. You can use a ruler. Okay, and I put it here. And then draw a line parallel to this side. To this side. Okay. Okay, I draw a line that's parallel to this one. And also we know this one is 1 and this one is 0, and the slope is 1.2 1 to okay 1.5 maybe 1.5. Okay. And so in this way let me measure 1.5 units. So because I have received many homework, the same problem is you don't know how to measure, how to draw the horizontal distance, and usually you label here is 1, but actually 1 is only this small one, and so it must be wrong for you if you label this distance is 1. Okay, so in the scale ruler, 1 unit is from 0 to 1. This distance is the unit 1. And but you usually I receive your homework, and many students label here 1, label here 1, but it is not 1. Okay, so I will draw a line parallel to the line, to this line. Okay, and then there is a problem about this plate. This plate is 1, and this plate is 2, and this plate is 3. And so how about this plate? How about this plate? How about the the slope foot line? Uh, between these two plates. So the difference is 3 minus 1 is 2, and the slope is 1 to 1. So I have to use this. Because this distance is 2. This distance is 2. Okay, and I put it here, and then draw a line through this point. Parallel to this one. And then you can see, as for this plate to this plate, the difference is 1, and the horizontal distance is also 1. Okay. Okay, I measured the distance that is 1. I put it here, and then draw a line through here. Okay, so I will minimize it. So, and then you can prolong this line and this line. Why? So because they are these 3 lines, these three lines are at the same elevation. The elevation is 1. So we can join it, we can put it together, and we can get a cross point. We can get a cross point. And these 3 points, this one, this one, this one, are at the same elevation. The width is 0. Okay. And then I along it. Okay. And then we have to draw the intersection line between two slope. Okay, and delete it. Delete it. Okay, that is the final. That is the result of your homework. So, as I hope that you can repeat it again. Because I didn't see anyone who do it perfectly, perfect. Okay, so I hope all of you can understand this step to draw this homework. So anyone have a question? Hello? If there is no question, I will start the next homework. I will tell you how to do it. Okay, so please remember, it must appear in the final exam, and the figure, the number will not the same. So you have to know how to draw, and in the final exam, the slope and the elevation are different with your homework. So you have to make sure that you have control how to draw this kind of thing. So so you can imagine this is like a pit. There is a pit, and with a different bottom, with a different bottom in every region. Okay. Okay. So the next one is much easier than it. It's much easier than it. For example, like this. Okay, and I'll draw. So I can copy the scale ruler. Okay, copy the scale ruler. No? Sorry. I have to draw it again. Scale ruler. So the scale ruler is very important. It's very important for you. So you have to use the scale ruler to measure the horizontal distance. So please. Okay, is it 0? and this one is 1, and this one is 2. Okay. So as for this one, if the bottom is 4 minus 3 minus 6 is is a 6. I think it's like a 4. Okay, and here is minus 4. Okay, this is 4. This is 6. This is 6. And then the slope, all the edge, all the slope around this pit, all the slope is 1 to 1. Okay, is 1 to 1. And so the difference is 4, is minus 4.
Lakshya, it's 2 into 1.
So what?
Lakshya, the slope is 2:1.
So I I can't, I don't know. 2 1. Okay, you can tap, you can tap to me. Okay, let me see. Okay, 2 to 1. Oh, it's okay. So I just set it as an example. Don't worry, okay? Okay, okay, I know. Okay, because in the examination, the question are not same with your homework, so you have to know how to draw up, just not just the results. Okay, uh, so I set it. Okay, I will follow you as a 1. Okay, as a 2 to 1. Okay, and you can see the difference of the elevation is minus 4 and minus 6. Okay, and equals to 2. And the slope is 2 to 1. And so you can calculate the error is 1. It's okay. So how can we calculate 1? How can we measure 1 distance? So I have to use the line that with the units is 1, and then rotate. And so now this distance, please look at here. This distance is 1. It is not the distance what you like. It is measured from the ruler, scale ruler. Okay, so then I will draw a line that is parallel to the side, parallel to the side, to this side, and with the same way, I will measure many parts. Okay. Okay. And then now I can draw many lines. That. Oh, okay. is good. Okay. And this one. This one is here. And this one is here. Okay, I prolong some of them and connect it together. Connect together. And then please draw a line that is connect the the cross point. Cross point. So you can get the cross section line. Okay. And then delete. Delete. And then you have to draw a slope line. It shows that the slope's direction is from top to the descending direction of the elevation is from the top to the bottom. Okay, it means that the slope is from this direction. It's this direction. Okay. This one I forget. Okay. Okay, maybe in the final exam, I will change the elevation into 8, into 8 and 5. And so maybe all of you can know how to draw it. Okay.
But you have a question.
It means that all of the slope, the direction of the slope is from top to the bottom. This area is higher than the bottom than this place. Okay, so now it's the
But
result. It's the result.
I have a question, Lash.
Okay.
Yes, so in the examination, when you send the questions about this topic, do we have to print them out or we're going to draw the diagrams using pencil?
Yes, all the questions in the examination you have to use a pencil, not a pen.
No, I mean, as in for this type of questions, where we have to draw the diagram. Since it is a specific scale, how are we going to know that this is the exact scale I have drawn on my paper?
Oh, I will give you a scale ruler in the examination. I will give you a scale ruler like this.
So, should we have to print the paper, right?
Yes, yes. I think that usually I will send you the PDF file, and then you have to print it out.
Okay.
And then if when you finished the exam, and then I think you can take a picture. You can take picture, but you have to take picture very clearly, so that I can see any details, every part of your paper. Okay.
Okay, love.
And there will be for the examination there will be 6 or 7 graph you have to draw. Okay.
Yes, so, Laji,
Okay.
Let's say maybe the exam is.
So what?
Yeah, for example, the exam is 2 hours, yeah? Then this type of questions, since you said we will have to print them out, are you going to send the PDF the previous day before the exam, or?
You mean that I have that I have to send you the PDF document maybe 1 or 2 days before the examination?
Yes, specifically for these questions, because Laoshi, if you say that you just display the questions, or you just send the PPT without printing them out, it would be kind of hard to just like write them on paper with the exact measurements as on the paper. I don't know if you understand what I mean.
Sorry.
Let me type.
Said that we need to print them.
Yeah.
So we can get the right measurement.
Direct measurement.
Laoshi, let me type in the WeChat group.
Okay. You can type it in the WeChat group. And maybe I will give you 6 or 7 questions, and 2 of them is about the topographic drawing, and others are for the three direction views or the section views and the cross section views. And because this week we will I will tell you the rest of part of our class, and in the next week we are going to do the reviews about the section view and the cross section view, and all the questions is on your on your exercise book. Is that on your exercise book? It will not so hard. So I will choose the simplest questions for you. Okay, as for this question, can you understand about this one? And okay, if you understand, and we'll go on the new part, because our class its name is engineering drawing, and okay, I see. The concern is about these questions, since they have specific measurements, and the scale rule will help to print the program out to have the same measures as yours. To print the question paper out to have the same measure as yours. A day before. Specific measurements. Oh, okay, I know. So you mean that specific measurements. The skill we have to print the question paper out. Translate.
Actually,
Oh,
I mean, we can't
okay.
get the exact measurements as
Oh,
yours if we just draw by pen.
okay. I think you can print it out with the A3 paper. A3 paper, and all the questions I will I will give you the questions is on the A3 size of A3 paper. If you use the A3 paper, print it out, it will be same. Okay, and the scale is not important, because if you print the question in a small paper, and the scale ruler will be small together. Okay, so don't worry. Don't worry. So, what you draw is depends on your scale ruler. Okay, I will use your scale ruler to measure your distance, and not my scale ruler to measure your distance.
Okay.
Okay. Okay. I know what's your meaning. Okay. Okay. So, no problem. Of course, I will send it before, and I will discuss this with. Um I will discuss this with the teacher Peng. So because I'm not sure if you can print it out early. If I think if you print it out 1 or 2 days before the examination, and you maybe you will check, you will ask how to draw this and how to draw that, and you will uh, uh, you will discuss it with each other. So it's a problem. Okay, so I will discuss this with teacher Peng. So how to do the examination? Maybe maybe I think actually it's a very hard problem. It's a very big problem, because if I it's because it is a drawing. It is a drawing. It means that you can't watch the screen and answer the question. You have to print it out. And I know that not all, and you don't have printer, and you have to print it before. You have to print it before the examination. I okay, so I think I will think how to solve this problem. Okay, so that's finished our class.
Maybe Lashi,
Okay.
on this situation, assignment is better for not as an exam, but I think assignment is better for this situation because we are not in China. We are all outside of China.
Yes. I know. Okay, so in fact,
Maybe it's better to discuss with Pong Laoshi. Maybe he will give us some better suggestion.
I trust you. I believe in you. So okay, I think that I can give you the questions before the examination, 1 or 2 days. I think I can. Okay, but it depends on the professor. It depends on the teacher. Peng. I have to know how to arrange the examination. Okay, it's the first time to teach you with the with the internet. It's the first time for you. It's the first time for me. Okay,
It's okay, Laoshi.
I have to face this problem. Okay, so let's go on.
Okay, Laksh.
Okay. Okay, it depends on teacher Peng, and I will discuss with her. Okay, so the homework is okay. The homework is okay, and because let's continue. Let's continue. Because our class is engineering drawing. So and from the start to now, we have learned about the section view, about 3 views, section view, about AutoCAD, and about the topographic drawing. So engineering. So where is the engineering? So this class and the next class, I will explain the engineering drawing in many different kind of construction site. In many, for example, the reinforcements concrete, the road engineering, and the bridge engineering, and also the culvert engineering, and so on. Do you have learned about? Have you learned the introduction to civil engineering?
Yes, Lashi.
The introduction to civil engineering, and you know the reinforcements concrete, the road engineering, the basic knowledge about this area. Do you know?
Yes, Lashi.
Yes, Laksh, we this semester we read about this.
Okay. Okay, so before the next part of this class, I think that I will show you a video about, because today we are going to learn the drawing of the reinforcements concrete and the steel bar. So let's watch a short video about why concrete needs reinforcements, and it will help you to understand the drawing better. Okay. I will share the screen with you.
In the last video, we talked about Concrete 101 and why concrete is such a great construction material, but I didn't mention its greatest weakness. Hey, I'm Grady, and this is Practical Engineering. On today's episode, we're continuing the series on concrete with a discussion of reinforcement. This video is sponsored by Skillshare. More on that later. To understand concrete's greatest weakness, first we need to know a little bit about mechanics of materials, which is the fancy way of saying how materials behave under stress. Stress in this case is not referring to anxiety or existential dread, but rather the internal forces of the material. There are 3 fundamental types of stress: compression, pushing together, tension, pulling apart, and shear, sliding along a line or plane. And not all materials can resist each type of stress equally. It turns out that concrete is very strong in compression and weak in tension. But you don't have to take my word for it. Here's a demonstration. These 2 concrete cylinders were cast from the exact same batch, and we'll see just how much load they can withstand before failure. First, the compressive test. Under compression, the cylinder broke at a load of about 1,000 pounds. That's 450 kilo. For concrete, that's pretty low because I included a lot of water in this mix. The reason is my rig to test tensile strength isn't quite as sophisticated. I cast some eye bolts into the sample, and now I'm hanging it from the rafters in the shop. I filled up this bucket with gravel, but it wasn't quite enough weight to fail the sample, so I added another dumbbell to push it over the edge. The weight of this bucket was only about 80 pounds, or 36 kilos. That's less than 10% of the compressive strength. All this to say, you shouldn't make a rope out of concrete. In fact, without some way to fix its weakness to tensile stress, you shouldn't make any kind of structural member out of concrete, because rarely does a structural member experience just compression. In reality, almost all structures experience a mixture of stresses. That's no more apparent than in the classic beam. This particular classic beam is homemade by me out of pure concrete here in my garage. Applying a force on this beam causes internal stresses to develop, and here's what they look like. The top of the beam experiences compressive stress, and the bottom of the beam experiences tensile stress. You can probably guess where the failure is going to occur on this concrete beam, as I continue to increase the load. It happens almost instantly, but you can see that the crack forms on the bottom of the beam where tensile stress is highest and propagates upward until the beam fails. You see what I'm getting at here? Concrete on its own does not make a good structural material. There are just too many sources of tension that it can't resist by itself. So in most situations, we add reinforcement to improve its strength. Reinforcement within concrete creates a composite material, with the concrete providing strength against compressive stress, while the reinforcement provides strength against tensile stress. And the most common type of reinforcement used in concrete is deformed steel, more commonly known as rebar. I made a new beam with a couple of steel-threaded rods cast into the lower portion of the concrete. These threads should act just like the deformed ridges in normal rebar to create some grip between the concrete and steel. Under the press, the first thing you notice is that this beam is much stronger than the previous one. We're already well above the force that failed the unreinforced sample. But the second thing you notice is that the failure happens a little bit slower. You can easily see the crack forming and propagating before the beam fails. This is actually a very important part of reinforcing concrete with steel. It changes the type of failure from a brittle mode, where there's no warning that anything is wrong, to a ductile mode, where you can see the cracks forming before a complete loss of strength. This gives you a chance to recognize a potential catastrophe and hopefully address it before it occurs. Rebar works great for most reinforcement situations. It's relatively cheap, well tested, and understood, but it does have a few disadvantages. One of the major ones being that it is a passive reinforcement. Steel lengthens with stress, so rebar can't start working to help resist tension until it's had a chance to stretch out. Often that means that concrete has to crack before the rebar can take up any of the tensile stress of the member. Cracking of concrete isn't necessarily bad. After all, we're only asking the concrete to resist compressive forces, which it can do just fine with cracks. But there are some cases where you want to avoid cracks, or the excessive deflection that can come from passive rebar. For those cases, you might consider going to an active reinforcement, also known as pre-stressed concrete. Pre-stressing means applying a stress to the reinforcement before the concrete is placed into service. One way to do this is to put tension on the steel reinforcement tendons as the concrete is cast. Once the concrete cures, the tension will remain inside, transferring the compressive stress to the concrete through friction with the reinforcement. Most concrete bridge beams are pre-stressed in this way. Check out all that reinforcement at the bottom of this beam. Another way to pre-stress reinforcement is called post-tensioning. In this method, the stress in the reinforcement is developed after the concrete is cured. For this next sample, I cast plastic sleeves into the concrete. The steel rods can slide smoothly in these sleeves. Once the beam cured, I tightened nuts onto the rods to tension them. Under the press, this beam wasn't any stronger than the conventionally reinforced beam, but it did take more pressure before the cracks formed. Also, this one wasn't quite as dramatic because instead of failing the actual steel rods, it was the threads on the nuts that failed first. I hope these demonstrations help show why reinforcement is necessary in most applications of concrete, to add tensile strength and to change the failure mode from brittle to ductile. Just like the last video, I'm just scratching the surface of a very complicated and detailed topic. Many engineers spend their entire careers studying and designing reinforced concrete structures. But I'm having some fun playing with concrete, and I hope you're finding it interesting. I'd love to continue this series on concrete, so if you have any questions on the topic, post them in the comments below. Maybe I can answer them in the next video. Thank you for watching, and let me know what you think. Thanks to Skillshare for sponsoring this video. Just about every step of producing a video for this channel is something I learned to do.
Okay, so okay, I close the sure. Okay, so let's have rest for 10 minutes. And then I will tell you how to read the engineering drawing, how to read the reinforcement concrete drawing with the rebars. Okay. Okay, let's have rest.